In this video, we're going to practice going back and forth between exponential and logarithmic equations. The big important idea here is that every exponential equation has a logarithmic equation that expresses the same information, and every logarithmic equation has an exponential equation that expresses the same information. The first equation that we'll look at is 5 cubed equals 125. Here, 5 is the base, so when we write it in logarithmic form, we'll have a base of 5. The inputs and outputs get swapped, so 125 becomes the new input and 3 becomes the new output. For our second equation, we'll look at 2 cubed equals 8. In this case, 2 is the base, so I'm going to have a log base 2. And again, the inputs and outputs are swapped, so 8 becomes the input to the logarithm and 3 becomes the solution. Next, we'll look at going the other way, starting with a logarithmic equation and rewriting it as an exponential equation. It will be helpful to remember that a logarithm that doesn't appear to have a base is actually the common log, a log base 10, and ln is used to mean the natural log, or log base e. First, we'll look at log of 5 equals x. Again, because there isn't a base, this is really meant to be log base 10. So when we translate this into exponential form, our base is 10, the exponent is x, and it equals 5. For our second problem, we'll look at the natural log of 5 equals x. Again, this one doesn't seem to have a base, but it's really log base e, the natural log. So when we translate it into exponential form, our base is e, the exponent, in this case, is x, and it equals 5. Finally, we'll look at a really abstract example with no numbers. Log base b of y equals a. My base is b, the exponent is a, and it equals y. You can use this one as a roadmap for how to translate all logarithms into exponential form.